This is example 3.1 in the textbook on page 85. So again, we're considering the example 2.1 where we have the contractor wanting to determine what's the probability that a certain number of bulldozers will remain operational after 6 months. They have 3 bulldozers. So what we did in example 2.1 is we grouped them we wrote out the sample space, and now in 3.1 what we want to do is group all of those different outcomes into the categories where we have none of the 3 being operational, 1 of the 3 being operational, 2 of the 3 being operational, and all 3 of the 3 being operational. So recall that we have O is equal to operational and N being non-operational. So we had we wrote out the 8, and recall that there were 8 possible outcomes for these 3 bulldozers, and I'm just going to jump ahead and group it into these categories where 0 is going to be the number of operational, we're going to count up the number of operational bulldozers after 6 months, and there is the case where we have none of them operational. This would be 0 operational, and there was only 1 single outcome like that. The case where we had 1 operational, we could have either ONN or NON or NNO. In the case where we had 2 that were operational, we could have OON, we could have ONO, or we could have NOO. In the case where we had 3 of them that were operational, there was just a single event of all 3 of them being operational. So recall that this is 6, 7, 8 total possible outcomes in our sample space. So we wrote out all the possible outcomes. So what we want to do here is draw up both the PMF and the CDF. Because this is a discrete problem, we have a PMF, a probability mass function, that is defined by our random variable x. So this is going to be our random variable x. And this we're going to plot up versus the probability for each of those individual outcomes. So the first probability is 0, and we had 1 out of 8 for here. 1 possible scenario out of a total possible number in the sample space of 8 gives us a probability of 0 being operational after 6 months of 1/8. So we plot up the value 1/8 at the 0 marker. For 1, the probability that 1 would be operational after 6 months is 1, 2, 3/8. So we plot up 3/8. And likewise for 2, we have 3/8 here, and then again 1/8. So each of these are the individual probabilities. So this is Px of x in this column down here. And that's what we'll plot up for 2, 3, and that's the only number that we have. So 1/8, 3/8, 3/8, and 1/8. This is what the probability mass function looks like for this problem. We can also plot up the CDF, which is the cumulative summation of all of these, rather. So at 0 we have 1/8, so we start here at 1/8, and then we go to 1, and we had 3/8, so 3/8 on top of 1/8 is 4/8 or 1/2, and then we go to 2, we got a half, and we add another 3/8, so 3/8 on top of a half is 7/8, and then we add the last value of x, which is 3. There's a 1/8 probability there, so 1/8 on 7/8 gives us a value of 1. So this is what the CDF looks like of the random variable x for the discrete case. It's pretty straightforward in this particular instance, where we're simply able to write out the entire sample space and evaluate it in this manner.